In several of the videos in the bioinformatics playlist, I've shown you how you could apply machine learning in order to build a model that will be able to predict the solubility of molecules and also the biological activity of molecules using original dataset, where I've shown you how you could collect it, pre-process it, and then build a machine learning model. But all of that was performed using the Python language. And so in this video, we're going to be taking a step back and looking at a no-code machine learning software called Weka. And we're going to apply that in order to build a machine learning model that will be able to predict the biological activity of molecules. And I'm going to be showing you that step by step, whereby we're going to take the SMILES notation and we're going to be calculating the molecular descriptors or the fingerprint descriptors. And then we're going to be using it in order to prepare a input data set. And then finally, we're going to be building machine learning models. And so without further ado, we're starting right now. Okay, so for this tutorial, we're going to be using the dataset from the HCV PRED paper, which is one of our recent paper published earlier this year in May of 2020. And so for those of you outside of academia, you might not be able to access this full paper. And therefore, I will tell you the link where you can download the dataset, because in the paper, in the materials and method, it will be talking about the GitHub link. And so you want to head over to the github.com/channonlab/HCVPred. And so the dataset will be inside the file here, HCV NS5B curated.csv. And scroll a bit down and you'll find the raw button. So you want to right click on it, and then you want to click Save Link As, and save it to desktop or to your working directory. And so let's open it up. So I've downloaded and it became a text file. So let me rename it, changing txt to be CSV. Okay, now it's a CSV file. Let me double click on it. Okay. So since I'm on a Mac, it's opening up the Numbers app. So you're going to see the first column is the Chambo ID. So this is the unique identification number of each of the compounds. So each row will constitute a unique compound, because in this data set, we have already curated it, meaning that each of them are non-redundant, because we have already removed the redundant compounds. And so the second column will be the canonical SMILES. So essentially, it is the SMILES notation. Third column will just be telling that it is the IC50 unit. For the IC50 unit values, it will be on the standard value column, and then it will be in nanomolar units. Okay, and then if we converted the nanomolar unit into PIC50, which is the negative logarithmic transformed value of IC50, we're going to be getting this column. And the reason for doing so is because the log transformed version will allow the data points to be more uniformly distributed. Otherwise, the values will be clustered together and there might be present of many different clusters in the same plots. And so that's essentially what we need to use from this file. Okay, so next step is you want to head over to Google, and then you want to search for PaDEL, and you want to type in PaDEL-Descriptor. And then if you want to read the full paper, you can read this PaDEL-Descriptor file, or you could click on the first link, which will bring you to the PaDEL website. So you want to scroll down and find the download link, which is right here. And then you want to save link as, and then download it to your computer. So here I have downloaded to the desktop, and let's unzip it. And let's look at the contents. So the descriptor.xls will be telling us the type of descriptors that we are able to calculate from the PaDEL software. And so PaDEL will essentially allow us to calculate molecular descriptors and also molecular fingerprints. So the first tab here will be telling us the list of different molecular descriptors that it will be able to calculate. So these are the classes of descriptors. For some of them, like for example, the atom count. So this is the class of descriptor, meaning that it will be comprised of the following: the number of atom, the number of heavy atom, etc. But some of them might be containing only one descriptor. And if you look to the right here on the bottom tab, you're going to be seeing the different types of fingerprints that are available from PaDEL. Okay. And for this tutorial, we're only going to be making use of the GUI interface. But for those of you who are interested in using PaDEL-Descriptor in a command line or embedding this into your own Python or R script, then you want to check out the descriptor.xml, where you could modify the contents in order to select the appropriate descriptor that you want to calculate. So I might be showing you that in another video. And so let's open up the PaDEL-Descriptor. Okay, and so this is the PaDEL-Descriptor. So right here, molecules directory file, you want to click this. But actually, we have to create the input files for PaDEL. So we want to go to the data set of the compounds that we're going to make use of. Let me do this in Excel. I'll right click, open with Excel. And so I'm going to copy these two columns, and I'm going to create a new file. I'm going to delete the header, and I'm going to move the first column, the name, to the third, and then delete the first. So essentially, we will be starting with the smiles notation, and then we're going to have it followed by the name or the Campbell ID, and then we're going to save it. So let me save as a tab delimited file. To desktop. So I'm going to call it hcv.smi. Save. So make sure that you want to show the extension of the file. And so we see that it is ending with a txt. So I have to make it SMI because that's the file type that the PaDEL software will be recognizing. All right, so in the PaDEL-Descriptor GUI for the first tab in general, in molecules directory file, you want to click on the ... found to the right, click on the button, and then you want to click on the location where you want to access the files. So it's on a desktop, and then the name of the output. So after calculating the descriptor, let's call it descriptor descriptor.txt, or actually descriptor.csv, because it's going to be outputting a CSV file. And for the descriptors that we want to calculate, let me select fingerprints. Okay. And then for the standardize, you want to click on remove salt, because earlier on I told you that there are the presence of salt and other small molecules. And you want to detect aromaticity, and you want to standardize the tautomer. So click those options. And also standardize the nitro group. Okay, and that's all for here. And you want to click on the fingerprints tab, and then the descriptor that we're going to be using today is the PubChem fingerprint. So this is already selected at default, so we're going to leave it there. But if you would like to try out different types of fingerprints, feel free to untick it and try another one. Okay, so we're going to stick to the PubChem one and click on start. Okay, and so here you're going to see that the molecules are processing. So if this is occurring too fast, then it means that there might be an error. But if you're seeing this and it's taking time, you're going to see the progress bar slowly moving up, then it means that you have done it correctly. So here it's going to take about 0.09 seconds per molecule. And in no time, it will be finished. A few more. All right, so all of them have been calculated in about 47 seconds. Click on OK, and that's all for the descriptor calculation. So make sure that you see the presence of the output. Let me find it. All right, so it's in the PaDEL-Descriptor folder in the descriptor.csv file. So I'm going to move it out to the desktop. All right, and so if you see this, if the file is not blank, then it means that it is okay. Okay, so let's have a look. All right, everything looks good. And so now let's continue to preparing the data set in ARFF format. So let me switch to Microsoft Excel so that it's familiar also to the Windows user as well. So open with Microsoft Excel. All right, so first thing is you want to click on the entire first row, which is the header, right click, and then you want to copy it. Okay. And then the next step is you want to create a new file, Control N or Command N if you're on a Mac. And then you want to paste the content, but you want to right click on it. You want to right click on the first cell, on cell number A1. You want to right click, and then you want to click on the paste special. And then make sure to tick the transpose option found at the bottom. And then in the paste, click on the values. All right, so transposing will convert from the wide arrangement into the vertical arrangement, like from horizontal arrangement of the values to the vertical. So right here, I mean, like this, okay, from the row into the column format. And the reason being is because you don't want to have to type in all of these manually. All right, and then next step is to delete the first row. Okay, and then you want to insert a column before it. So right click on cell A and click on insert. And then you want to type in here at attributes. Okay, it doesn't work, so let's try. So you click on it, you type it, and then you want to cut. Okay, otherwise, because if you type it in and then you hit on enter, you'll get an error message. Okay, it doesn't recognize this format. So you want to type it and then you want to cut it out. Okay, and then click somewhere else and then click back again and then right click and then paste. Okay, now you could paste the value in there. And now the tricky part now is, let me zoom it up first. Make sure that you find the small square at the bottom right of the cell A1, and you will see that it changes the cursor to a black plus sign. So you want to click and hold and then scroll down. And so essentially, you're going to be duplicating the value of A1 to span the entire column. Okay, and wait for a while because there are a lot of descriptors. Okay, there you go, about 881. And then you want to do the same because they're all numerical values. So you want to type in numeric and then do the same thing. Okay, and now you want to copy everything. So you want to click here, copy, and then open up your text editor. So I have Atom, and so I'm going to open up Atom. And then you want to create a new file, Control N or Command N, paste it. Okay, so it's containing a lot of empty data here. So we're just going to delete it. Okay, there must be a better way. Let me know in the comments. Okay, there I go. And so I'm going to delete the other blank values. Okay. Okay, and here I'm going to add data. And into the top, I'm going to add the relation, followed by the name of the dataset. Add relation and the name of the dataset. Just call it HCV. Scroll down, and then in the add data, I'm going to add the CSV data in just a moment. So here, let me close this Excel file. And for this, I'm going to take the values of the first column, scroll down, scroll to the right, and I'm going to collect only the data values here. I'm going to create a new file, then I'm going to paste it here. And scroll to the far right, and then I'm going to paste the IC50, the PIC50 value here. So it might be a bit confusing. For this file, we'll move it, minimize it first. For this one, okay, so let me find the file that we downloaded from the GitHub, which is this one. Let me open in Excel. All right, so we're going to copy the PIC50 values. And it's right here. Make sure again, is it PIC50? It is. Okay, copy it. Head over back to the file that we have already opened. And then in this last column, we want to paste the values here. Okay, make sure that there are no missing values. All right, so it matches the dimension exactly. All right, very good. And now for this, we want to export it out as a CSV file. So you want to click on File, Save As, and then file format, you want to click on the comma separated value. You could call anything, I'll just call it at the default book 2, save it. And then I'm going to load in the book2.csv into Atom. Just drag and drop. And then I'm going to select all values. So essentially you could just press on the Command A or the Control A, and then Control C or Command C in a Mac. And then you want to paste it here. So Command V or Control V. And that's essentially it. Now we're going to save it. We're going to call it hcv.arff. Save it to desktop. Right here. And now we're going to open it up in Weka. Alright, so in Weka, you want to click on the Explorer button. Okay, and open File. Go to Desktop. Click on hcv.arff. Alright, so it works perfectly. It loads in. And there are, as you see, 881 attributes and 578 compounds. Oh wait, okay. It seems that I forgot to do something. Okay, let me go back to Atom. And then I need to drag and drop the HCV ARFF file again. Okay, I forgot to add the add attribute for the PIC50. Let me do that right now. So right before add data and before the end of the add attributes, I want to add another line. I'm going to call it PIC50 and then numeric. Save it. And then open again, hcv.arff. Alright, and so to the right here, you're going to see class PSC50. If you see that, it is correct. And 882 is the PIC50. Okay, and now the attributes update itself to 882. And so now let's do the data preprocessing. So in the preprocess tab, in filter, you want to click on choose. And you want to click on the drop down of filters. You want to click on the unsupervised. You want to click on the attribute. And then find remove useless, because some features will have no variation at all. So you want to remove that. And now you want to click on apply. And notice that the descriptors have been reduced to 550 because 300 or so have no variation in the data values. Okay. Now we're ready to build our model. Let's click on the Classify tab. In the classifier, click on Choose. So for this, we're going to use the random forest. So under Trees, you want to click on Random Forest. And let's try the Use Training Set. And click on Start. All right, and so we see that the correlation coefficient is 0.9821 with a root mean squared error of 0.2509. And let's try the cross-validation. And we're going to set the fold to 10. Click on Start. And now you're going to see that correlation coefficient for this is 0.8565. And RMSE is 0.6399. Percentage split, let's try 80-20. Click on Start. Okay, and the correlation coefficient is 0.8516 with a root mean squared error of 0.6719. Okay, so notice here that you're not getting any predicted values out in the results here. So what you want to do is click on the more options, and in output predictions, you want to click choose, and you want to click on CSV. Click on OK, and let's try it again. Okay, so the prediction now is in CSV format. So for this, you could just highlight and copy it. But actually, this is only for the test set. So let's do it for the training set first. All right, so here we have 578 data predictions. And so, or actually, you could just Command A here. Command A or Control A, meaning you click on the window here, Control A or Command A, it will select everything, and then Command C or Control C to copy it. Head over to Atom, and then you wanna, you're gonna open up a new file, Control N or Command N in Mac, Control V or Command V, paste it, and then you wanna delete the results at the bottom, and then you wanna delete the top part as well. And therefore, you now have a CSV of the predictions. So you want to save this as the results dot, but let's call it something too, results underscore training dot CSV. Close it, and let's visualize it in Excel. All right, there you go. You have the results here, and you could easily create a scatter plot to look at the prediction results. So click on Insert tab in Excel and find this scatter, XY scatter, click on it. And all right, and essentially you're gonna be seeing values at the middle being removed because for this data set, we originally intended to use it for performing classification. So values within the range of 5 and 6 were removed. Okay. So nevertheless, the methodology used in this tutorial could be applied to perform regression. And if you want to do classification, then essentially we have to do a little bit of a hack. Here, let me show you. Because now we know that the values in between were removed because it serves as like a threshold. And so values here are inactive, values here are active. So let's proceed to converting our data set into a classification form. So what should we do? Let's go to the SCV. Okay, and we wanna, let me open it in Excel. So for the PSC50, okay, I'm gonna copy that column, open up a new file, paste it, and then I'm gonna use Excel, and I'm gonna say if A2 is greater than 6, we're gonna call it active. Otherwise, it'll be inactive, and we're gonna use, okay, let's try that first. It doesn't work, so let's add the quotation. All right, there you go. However, instead of inactive, let's see, otherwise it will be less than 6 will be inactive. So we have to say 5. So instead of saying inactive here, we're going to replace it with another if. We're going to embed another if. So if A2 is less than 5, it will be inactive. Otherwise, it'll be intermediate. But actually, there's no intermediate file, so we shouldn't be seeing intermediate. Let's try it. Copy it to the rest. Inactive. Okay, so here we're seeing inactive, inactive. Hopefully we're not seeing any intermediate. Okay, let's check it. Okay, so it seems that we have already sorted the value. So value starting on line number 414 is inactive. Okay, and it's less than 5. All right, so this is correct. So now what we want to do is we're going to use this in just a moment. We're going to head over to the descriptor file, .csv, open it up. All right, and then we're going to copy the contents again, the numerical data contents again, and then open up a new Excel file, paste it, scroll to the right, and for the last column, we're going to paste the class label, which is right here. We're going to paste this. So you want to copy only the values. Copy. And then right click, paste special, value. Okay. There you go. Let's make sure there's no missing values. All right, perfect. Now you want to click on the entire data values here. Copy. All right. No, actually, we could just save it. Let's close this. Okay, and this value, we're going to save it in just a moment. Okay. So we're going to save it as CSV. Desktop. So file format, we're going to use comma separated values. Before we call it book 2, right? Let's call it book 3 now. But actually book 3 is the classification version and book 2 is the regression version. All right, and so why don't we rename this to be HCV and then let's call it regression. And then you want to copy that, duplicate it, and then let's call it classification. And open up your Atom. And let's open up the, okay, let me rename it. No copy here. All right, open up the file contents. And on the last add attribute, we're going to be changing that. Let's call it the class. And instead of numeric, we're going to use the braces. And then we're going to use active and inactive. And then the data here, we're going to delete it. Okay, and then we're going to open up the contents of book 3. And then we're going to Command A or Control A to select everything, Control C to copy it, and then we're going to paste it into the underneath the app data. All right, now we're going to save it and we're going to close it. Okay, now we're ready to open it up again in the Weka. Go back to the Preprocess tab, click on the Open File, and you want to click on the HCV classification. All right, and so it works perfectly. So same thing, we're going to use the remove useless feature again. Click on apply. So actually you could go here, go to filter, go to the drop down filters, go to the drop down unsupervised, go to the drop down of attributes, then find remove useless. Click on it and then click on apply. Now we also have 550 remaining for the descriptors, and you want to click on the classify tab. Okay, so we're going to use random forest as usual and click on the use training set. Click on start. All right, and the results give 99.827 accuracy. MCC is also pretty good, 0.996. Let's have a look at the tenfold. Tenfold is also pretty good. Accuracy is 90.48. MCC is 0.763. And so here you're going to see the actual value and the predicted value, that they're pretty much matching one another. And yeah, so now it works. Okay, so I've shown you how to build regression models and classification model using the same data set, with the only difference in that the last column will be either qualitative or quantitative. Okay.
If you're finding value in this video, please give it a like, subscribe if you haven't yet done so, hit on the notification bell in order to be notified of the next video. And as always, the best way to learn data science is to do data science, and please enjoy the journey. Thank you for watching. Please like, subscribe, and share, and I'll see you in the next one. But in the meantime, please check out these videos.